In this video I am going to explain the derivative of sine inverse x by first principle. So let y is equal to sine inverse x implies that sine y is equal to x. Let it be equation number 1. Now, if delta x is the increment given to x and the corresponding increment in y is delta y, so we have y sine y plus delta y is equal to x plus delta x. Let it be equation number 2. Now subtracting equation number 1 from 2, we get sine y plus delta y is equal to minus sine y plus delta y minus y is equal to x plus delta x minus x. So this x is cancelled by this x having opposite signs. So we have delta x is equal to sine y plus delta y minus sine y. Now applying the formula sine c minus sine d, which is equal to 2 cos c plus d upon 2 into sine c minus d upon 2, we may write it as 2 cos y plus delta y minus plus y upon 2 into sine y plus delta y minus y upon 2. In this, positive y, negative y cancelled out, and we have 2 cos y plus y 2y plus delta y upon 2 sine delta y upon 2. Now dividing both sides by delta y, we get delta x upon delta y is equal to 2 cos 2y plus delta y upon 2 into sine delta y upon 2 divided by delta y. Now taking limit delta y tends to 0 on both sides, we have limit delta y tends to 0 delta x over delta y is equal to limit delta y tends to 0, and this expression can be written as cos 2y or we may split these two terms also. 2y divided by 2 is y simply, and plus delta y upon 2. So this may be written as y plus delta y upon 2, and this 2 may be written in the denominator of delta y, because any number or any term from the numerator can be written in the denominator as the denominator of denominator. So we may write it as sine delta y upon 2 divided by delta y, this delta y, divided by this 2. So by the definition of differential coefficient, delta x upon delta y, when delta y tends to 0, can be written as delta dx over dy is equal to, and here on the right hand side if we apply the limit, so first term cos y plus 0, that is cos y, and in the next term, next factor, this expression with this limit makes the standard form of limit x tends to 0 sin x upon x, which is equal to 0. So applying that limit, we may write this value, we may evaluate this limit as 1. The standard formula for limit is when x tends to 0, sin x upon x is equal to 1. So this standard limit we have used in this case. So we have 1 here. So now take the reciprocal of this expression. We have dy upon dx is equal to 1 upon cos y. As we know that cos y may be written as under root 1 minus sin square y. So as we have assumed in the beginning y is equal to sin x, and by that we have inferred sin y is equal to x. So from here, if we substitute sin y is equal to x here in this expression, we have dy upon dx is equal to 1 upon under root 1 minus x square. This is the standard formula for the derivative of sine inverse x by first principle.